Hi Hassan, good afternoon.
Good afternoon.
Rita.
Good afternoon, Revati.
Good afternoon.
Good afternoon, Jalaj.
Hi, Greta, Hassan, Revati. How are you guys?
Fine, thank you.
Am I loud enough?
Yes,
Yes.
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 Great.
What about me, Jalaj? Am I audible?
Yes, very
Okay.
much. Very
All right.
clear.
Fine. Yeah.
So I just done solving this paper, the other paper. I mean the other question of that paper, paper
Yeah, got
3.
it. Yeah.
But yeah, surprisingly, we don't use calculator at all in that question.
It's a pattern that follows, right?
Yeah. So in the first question,
Right.
you have to use calculator. Without calculator, you cannot finish it in time,
Correct.
and
The C part.
possibly you can't even do that.
Yeah, for the
And
C
in
part.
yeah, in the second question, you don't require calculator at all because there is no number actually.
Right.
They're just variables. So
Yeah. We have four attendees already. Yeah.
great.
Hello. Hello. Am I audible, Hassan?
Yes.
Yes, yes. Thank you. Hello, ladies and gentlemen. Welcome you all for the webinar today. We Numerical Analytics Instruments hosting this webinar, and I'm Revati. I have my colleague Hassan. Today's topic is TI Inspire CX2 in assessment. We'll be solving IBDP exam questions from paper 1, 2, and 3, especially from AA and AI, and also exploring TNS files. We have two speakers with us today, Mr. Jalaj and Mrs. Greta Gomes. Welcome, Jalaj, and welcome, Greta. Jalaj is hi, hi.
Good
Okay. Yeah, we are having participants joining. Yeah, we'll start exactly at 3 p.m. And to give a short introduction about Jalaj and Greta, Jalaj is a IB and IGCSE math educator from Indonesia, and he's a TOK instructor. Jalaj is very familiar among the Indian educators now because he has been doing webinars for us since March. And we have a wonderful lady today with us, new speaker, Greta, Greta Gomes. Hi, Greta.
Good
And
afternoon, Revati.
hi, good afternoon. Yes, Greta is currently working in Stonehill International School, Bangalore. And Greta also has 15 years of work experience in teaching math. And she is also one of our TQ trainer, especially I want to highlight this. She's also one of our TQ trainers. And yes, welcome Jalaj and Greta. Now over to Jalaj.
Thanks. Thanks, Revati, for your kind words. And my apology, I'll be keeping my camera off because here on and off it's rainy season, and I, if I keep my camera on, then wavelength will be, I mean, this bandwidth will be compromised. So I don't want to take any risk. So my apology for this. Okay, so thanks, Revati, and thanks, Greta, for being here today with me.
My
And
pleasure.
I would like to welcome everyone to this another wonderful webinar. And thanks to Numerical Analytics for this wonderful session. Today we will explore the power of TI Inspire CX2 calculator, and we will explore it in approaching questions in a calculator paper in IB diploma. And as we know that in MAI, all three papers are calculator papers, and in MAA, that is analysis and approaches, in paper 1 we don't use, but in paper 2 and 3 we use it extensively. So today we will discuss various questions from May 21 session, and let's start today's session with a question from Applications and Interpretation paper 1 from May 21 session. And then we'll solve a question from paper 2, then question from paper 3, and there will be lots of interaction in between. If you have any question, or if you would like to ask anything, please post in the comment box and we will address to that as soon as possible. Okay, so let me share my screen and let's get started. Okay, Greta, can you see my screen?
Yes, Jalaj.
Lovely. Okay, so in MAI paper 1, there are like mixed questions, but none of them is like extended response question, but still there are questions which cover like good marks up to 7-8 marks. So to start with, let's go with this question. This is from May 21, MAIHL paper 1, question number 16. And this question is on Euler's method. So the question reads, a particle P moves in a straight line such that its displacement x at time t, where t is more than equal to 0, is defined by the differential equation x dot, which is actually x component, change in x component of velocity, is x cos t, e raised to the power of negative sine t at time t is equal to 0, x is equal to 1 upon e. So it is obviously an initial value problem in differential equation where dx upon dt is given. So your variables are x and t. So by using Euler's method with the steps length of 0.1, find an approximate value for x when t is equal to 0.3. This is a 3 marks question. And part B is by solving the differential equation, find the percentage error in your approximation for x when t is equal to 0.3. And it is worth 5 marks. Now, uh, while solving this question, we will see various approaches, most popular approaches, some classical approaches, and some approaches which are not conventional, but they're still very powerful. So let's get started. So let's try first with the concept of Euler's method. What is Euler's method and how do we use this? So basically, when do we use Euler's method? Sometimes we do not need to solve any equation, any graph, this differential equation. So we can generate or we can approximate the numerical solution of a differential equation without actually solving it. So what we can do is we can find the value of y for a specific x value. So how do we do this? Let me share on my screen here. Okay, so let's say you're given any differential equation. So typically we work for a first order differential equation that looks like dy upon dx is equal to function of x comma y, and usually you are given x naught y naught, means when x value is x naught, y value is y naught. So how do we use Euler's method here? Everyone knows that for Euler method, you would be asked for a specific value of x, like find what is value of y when x is xn. So this kind of question we can easily do with the help of Euler's method. So first thing we do is we check from x naught to xn. How are we moving? So you will always be given one step size here. In this question, this was given 0.1. We usually write it as h is equal to as h. So in this case, h is equal to 0.1. Then we use some iterations for values of x and values of y. So any value of x is always the previous value of x plus the step size. And for the value of y, we use yn plus 1 is the previous value of y plus h times the derivative of the function at the original point, that is x and yn. Now remember, out here we have two variables, x and t. We do not have x and y. So for x and t, how will this look like? So let's get started. So in this question, out here we have been given that x dot is x cosine t and e raised to the power of negative sine t. And the initial value is x is equal to 0 and y is equal to 1 upon e. And h is 0.1, that is the step size. So this we can write as dx upon dt is equal to x cos t divided by e raised to the power of sine t. We can also keep it as e raised to the power of negative sine t in numerator. So that's okay. Now in the examination, what is expected? What all should we show? We have two variables, t and x. So we have to show values of t and the values of x, and it can be shown in a tabular form. So we can show it in a table. What are the values of t? T starts from, if we see here, t starts from 0. Sorry, let me correct it. This is not x and y, this is t and x. So when t is equal to 0, x is equal to 1 upon e. So we start from 0, then we keep moving in a step of 0.1. So 0, 0.1, 0.2, and 0.3. So we will be moving in these steps for the values of t. Now, the corresponding value of x, when t is equal to 0, x is equal to 1 upon e. This is given, this has been given. Now, when t is equal to 0.1, how do we find value of x? So for this one, we need to know what is dx upon dt at the point, at the previous point. So out here, your point is 0, 1 upon e. So if you look at dy by dx, dx upon dt here, at this point, it will be 1 upon e, because x value is 1 upon e. So 1 upon e cos t means cos 0 divided by e raised to the power of sine 0. So that makes it cos 0 is 1, sine 0 is 0, e raised to the power of 0 is 1 again. So this is 1 upon e. So the next value of x will be 1 upon e times 0.1 plus the previous value of x, that is 1 upon e. So this will be 1.1 divided by e. So now when t is equal to 0.1 and x is equal to 1.1 over e, what will be the value of dx upon dt? So we'll write this one here. So it will be x is 1.1 upon e, and this will be cosine of x, that is cosine of 0.1 divided by e raised to the power of sine 0.1, and so on and so forth. So I calculated these values. So I would like to write these values here. And when you use the next value of x, the next value of x will be 0.441106, which is actually the previous value of x plus 0.1 times dx upon dt. And the final value at 0.3, this will be 0.476548. So in these small steps, when we move, then we can see that value of x is 0.476548 when t is equal to 0.3. Now, if we revisit the question, this is very important. Sometimes we lose track of what exactly we are doing. So the question is, by using Euler's method with the step size of 0.1, find an approximate value for x when t is equal to 0.3. So this is our approximation for the value of x when t is equal to 0.3. So this we can write as it means value of x when t is equal to 0.3 is equal to 0.47. Now, if we need to use this value, we will be using the 6, 7, 8 decimal places. But since we are writing this as our final answer for part A, it should be rounded off to 3 significant figures. If stated to 4, 5, 6, fine. Otherwise, we have to express it to three significant figures. So 0.477. I like this number, 0.477. This was number of my bike long ago. Okay, so this is the value of x. So it took us approximately 7-8 minutes. Now, this is, if you see, this was a 3 marks part of question number 2 in AA paper 2. So if we spend 7-8 minutes in a 3 marks question, it is not justified and we won't be able to complete this in time. So let's have a look at another approach. If we use a graphic calculator, how do we do this question with the help of a graphic calculator? So this is the question. Particle P moves along a straight line. Now, how to get this question? It's I can show it to you quickly to those who do not use TI calculator. You close everything. New, there are different kinds of pages. So you can open note. In the note, you can copy and paste as if you're doing in OneNote, or you're doing in Pages, or you're doing in a Microsoft Word. So I just copied it. So Control X is to cut, Control C to copy, Control V to paste. So I have pasted this. This feature is not available in any other computer, but only in TI. So there are some calculators which use the similar commands, but this kind of like detailed, versatile, and like one full package is not available in any other calculator. So this is our question. We will keep it in one of these pages. Now we will open a new page. To open new page, either we can say Control I, or we can go through the menu. So if you do Control I, this is how it looks. And if you are here otherwise through Doc, you can go to Insert, a new page. When you say new page, the similar menu appears. So this time we are going to solve it and see. We were using list, values of t, values of x, values of dy by dx. So we will add a list and a spreadsheet page, right? What is here? 2. Okay, never mind. So what we can do is I can delete number 2. I don't want this. So let me delete this page first. Yeah, this is my question and I'm solving it here. So the first one, I would like to have my t values. So I'll just label it as t val. And the second one, I would like to have x values. So I'll put as x val. Okay, now in the first one, if you remember, our question is right here. So we don't have to change the pages or go to the question paper again and again. By using Euler's method with the step size of 0.1, and the initial value is t is equal to 0. So let's start from 0. And the step size is 0.1. So 0 plus 0.1 will be 0.1. Next will be 0.2. Next will be 0.3. So what you can do is you can just select everything and you can pull, like simple spreadsheet or Excel document, or like in any other computer software we do similar way. So these are t values. Now what we are looking is, we are looking for the x values. What is the initial value of x? It was 1 divided by e. So initial value when t is equal to 0, value of x was 1 upon e, or say e raised to the power of -1. So you can write here as this as e raised to the power of -1 and enter. So this is the initial value t, this is the initial value x. Now there is one more very important thing which we need to use, that is the change, how your variables are changing. And that happens in terms of the derivative. So out here, in this case, what is dx upon dt? This is defined as x cos t raised to the power of negative sine t. So we will use the formula here. We will insert a formula, and it's very simple, is equal to. The formula is going to be, in the question it says x cos t. X means these values. So in B1, so I can put a bracket and B1, and cosine. Cosine, you can type cos, but I like to go through this template. So cosine, so cos of t. T means these a values. So cos of a1. Done. I move out of this. Then next will be e raised to the power of negative sine t. So usual e raised to the power of negative t. T is again in a1. So I'll go to a1 and negative a1. And you can put this in a bracket also and enter. So once it is entered, it shows e raised to the power of -1 only. And that if you compare it with our work last time when we did this here, this was, yes, it was 1 upon e. When t is 0, x and dy by dx are same. Very good. So let's move on. Now, we need to find the value of y now. Now you see value of y, we are using iteration. we are not adding a constant term like what we did for t. So we need to define this one also as the previous value of x, which is in b1. So you can just put a b1 in the bracket and plus h times h is 0.1 here, so 0.1 times dy by dx at the previous point, right? So dy by dx means c1, dy by dx will be c1 at previous point. So I'll just put c1 and enter. So we get 0.4047, right? And your work is almost over. Now you don't have to write anything. You don't need to define anything. What you will do now, just give some commands, simple commands here. So how do we do this? Just right click and put fill. When you put fill and when you scroll your mouse down, then these fields will be filled by the same formula that we are using before and the iteration. So come down till here and enter. Do you see there is anything here? There is nothing. Why there is nothing? Because we have not filled the third cell. In this third column, there is nothing. That is why these values are missing. But you can see there is a dash. Dash means it is awaited. So now what we do is we do the similar process here, fill. And once you fill values here, you see everything is there now. So the final value is 4765 when t is equal to 0.3. And when you click on this, double click. Okay, never mind. So, oops, what I did. 820. I know, but I did something here. Okay, so no problem. So let me fill it again. And yeah, it's done. So when t is equal to 0.3, it is 4765. And let's see if it is matching with what we did last time. 476548. Yes, it is matching. So either you can use the calculator or you can do it manually. If it comes in paper 1, obviously you will need to do manually. And if it is in paper 2, mind that this method, Euler's method, is there in both in AA and in AI. Okay, so you may need to use calculator. You may have to do it without calculator. So this is how we do. Now another one. Now I would like to show you one more method of doing the same thing.
Jalad, before you move ahead, we have a few of questions in the chat.
Yes, please.
Like Suhasini Rana asked, like, but we need to define variable h, isn't it? How does system know that h equals to 0.1?
Okay, how does system know that h is equal to 0.1? So Suhasini, right?
Yeah.
Okay, so Suhasini, if you see here, out here, when I defined this one, this one, sorry. Yeah. Do you see I wrote here B1 plus 0.1 times C1? So this 0.1 is actually value of H. And this will always be given in the exam. So you will have a numerical value of H. So out here, if you change H 0.1, if H is 0.005, just make it 0.005. See, H will not change. The T values will have a progression. They will go in arithmetic progression because you keep adding 0.1. When it comes to in this context, the T values will go in this arithmetic progression. In this context, when we look at the X values, we will have iteration. These X values will depend upon T values and the previous X values. So they will keep changing according to the previous values, but the H value will never change. So we are using H is equal to 0.1 here when we are defining. Does this answer your question?
Yes, Jalas, she says yes.
Okay, thanks. Any other question?
Yeah, one more. There is one lady, Indrani. She's asking, like, this can be done using Euler function from Scratchpad also. I think direct Euler function is the feature of CAS.
No, it is not. I'm coming to that. Hold on. I'm coming to that only. That is the next thing we are discussing. So either we do it manually, or we use the spreadsheet, or we can do it directly with the help of a function which who mentioned? Hassan, who
Yeah,
mentioned this?
which
This
Suhasini asked
Euler's,
the point.
Euler's function.
This Indrani ma'am and one.
Indrani. Okay. So yes, we can use. So that is the next thing we are going to do. So what we do is once we are done with this, we can have a new, we can insert a new page, new calculator page. And don't use Scratchpad. Scratchpad is for like simple basic calculations. If you are doing this simple calculations, how to convert money, or how to find some percentage somewhere. Otherwise, use pages and this docs, documents and all these. So this is very effective, and you can of course save it later and use it later. So the second one is we can use Euler's function. If you see in the calculator, this open book icon here in this calculator in the rightmost column, if you click on this one, it takes you to the library, or we call it catalog in calculator. So in this catalog, you have all the commands which are available in this calculator. So if you go to Euler's function, so just press E, it will take you to E. So in Euler's function, E, this is eigenvector, eigenvalues, and Euler's. So do you see we have a Euler's function here? So Euler function is expression, variables, dependent variables, then list of variables, and so on, so forth. So if you give this command to your calculator, in one command, you can find all the values, you can do everything. So what we do is either you can go to the catalog, otherwise you just type EULER in the bracket. So what all you need to put, if you look at this one, Euler, it says Euler expression VAR, DEP, VAR, VAR 0, VAR max, moving on, DEP variable 0. So it is in a typical calculator language. So if you simplify, what all you need to put here, first one, you have to put the value of dy by dx. So your expression. The second one will be your independent variable. Independent variable. What is your independent variable? Then after, you have to type what is your dependent variable. Then after, you have to make a list here. So for list, you use these curly brackets, and here you put the initial value, which is x. Not usually we use, and then last value we usually write as xn. Then come out of this list, and then the next command for this is the y value, and then finally what we have not used so far is the step size, so h. So we put where is h? H is here. So we put all these values in the formula. It will say error when I enter, because I have not defined any of these things. So it will say error, but still I would like to go to the next line. That is why I just entered. So this is the one. You have to use expression, independent variable, then your dependent variable, then a list of the values of your independent variable, your start value and your end value, and then y value, and then finally you have to put the step size. So for this question, in this context, if you see dx upon dt was x cos t e raised to the power of negative sine t. So what I'll do is I'll just put EULER, Euler. Some educationists call it Euler. So I think everything is correct. As long as you understand what I mean, or I understand what do you mean, it's fine. So this is x times cos t e raised to the power of negative sine t. So you can just write x, And make sure you use times. If you just write x cos t, your calculator will read this as one variable. So x times cosine of t. So for cosine, either you can type, but it's good if you use this one, cos t. For t, you can use t. This is another beauty of Nspire. In other calculators, you have fixed number of variables. You have to use like x, y, z, w, etc. Out here you can use anything as variable. So practically there are unlimited variables here. You can have all permutations, combination of these a to z, 26. So you can use any of these as variables. So this is cosine of t. Maybe I can put this also in a bracket. I can put this in a bracket, then move out of the bracket, then e raised to the power of e raised to the power e raised to the power of negative sine t. So I'll use this negative, don't use minus. This is for subtraction, this is for coefficient. My students do this often, so I remind them every time. Whenever I use this, I remind them. So it's my habit, so don't mind, please. So t, okay, this one. Now this is your expression, and what is your independent variable here? This is t, so just put t. Now it is fast. Your dependent variable is x, you put x. Now you have to put a list here. So list is out here. Your initial value is 0, and your final value that you're looking at is 0.3, so 0.3. And we come out of this, comma, what is your initial y value? Y value is 1 upon e. So you can go to 1 divided by e, or you can simply write e raised to the power of negative 1. So I'll write 1 upon e. And then finally, my step size is 0.1. So if I put 0.1, and that's all. So I just have to give a command and enter. Once you enter, you get a distribution here. So these are your x values, 0, 0, t values in this context, 0, 0.1, 0.2, 0.3, and these are corresponding x values. Now, if you look at the last value, x value 4765, and if you go back and check with our answer, which we did manually, 0.4765. And also, if you go and see this one out here is 4765. So everything is matching, means our everything here is correct. So there is nothing wrong here. Now, once you are done, sorry.
Jalaj, one quick thing. There was a comment someone had made earlier on about this feature that you just showed on the calculator of the Euler function. It is disabled during the exams. I think that's what the comment that I saw a couple of comments earlier that during the exams in the press to test mode especially, this particular function gets disabled, and that's correct. That's right. It doesn't work during the exam. However, there are other ways to go around it. That is probably why Jala just showed the the list spreadsheet. You could also use the notes page and come up with this method. But this option is there. It's there. So when students are using it in the beginning, they are not so used to the calculator. They don't know the different functions. They can use the Euler function, which is directly available. So the comment is correct that during the exams, when you are on the press to test mode, this particular function gets disabled.
Wonderful. Thank you so much for this feedback, and thanks, John. And so that is why we are using different ways, different methods. So if you feel that in press to test something is not available or disabled, use the next one. So we have different methods, right? So this is how we can use Euler's or Euler's method to estimate. Now, this was part A of the question. So let's quickly look at the next part of the question. It says, by solving the differential equation, find the percentage error in your approximation for x when t is equal to 0.3. So going back to my canvas here. So let's quickly solve it and see how does it work. So this is a simple variable separable, it seems. So this is part B. So dx upon dt is equal to x cos t e raised to the power of negative sine t. So it is a simple variable separable. So I can say dx upon dt is equal to, oh sorry, dx upon x. Dx over x is equal to cos t e raised to the power of negative sine t and dt. And when you integrate, this will be ln x. And in the right hand side, I think we can do it quickly. If you put sine x as u, then cos t, sine t as u, so cos t dt is du, so you get e raised to the power of negative u du. That gives you negative e raised to the power of u. So this will be negative e raised to the power of sine t plus a constant. Now, if you see initially at x is equal to, t is equal to 0, x is equal to 1 upon e. So when you put x is equal to, t is equal to 0, so e raised to the power of, so this is negative 1, so c is equal to 0 actually. Negative 1 is negative 1 plus c, so you get c is equal to 0. So what we see here is ln x is equal to negative e raised to the power of negative sine t. So this is the solution of this linear differential equation. So going back to the question quickly, by solving the differential equation, find the percentage error in your approximation for x when t is equal to 0.3. So when t is equal to 0.3, at t is equal to 0.3, ln x will be negative e raised to the power of negative sine 0.3. And when you calculate this, I solved it and it was coming 0.475141. So when you find the value of x using this, then x will be e raised to the power of 0.475141. And this is approximately ln t is equal to this. Hold on, I think this is the value of x, not value of ln x. Yeah, ln x is this much. So when you find the value of x, x was coming this much, 475141 from this equation. So you can try it in your calculator. You will find it as x is equal to 0.475141. So now it's simple. We are looking for the percentage error. So percentage error is simply like your calculated value minus original over original times 100 or other way. So you can find either overestimation or over approximation, under approximation, and so on and so forth. So this is how we can solve this question. We took lots of time because we used multiple methods. We had lots of discussion. Otherwise, this question in exam, it is worth 8 marks. So within 10 minutes, you can, our students can comfortably do this. Now, moving on with this, now what happens once you close this file? When you close this file, you will see there is a prompt. Do you want to save unsaved document? You may say yes, you may say no. So now what happens here? Let's quickly go back and have a look here. Once again, so, sorry, this one. My mouse says start. Okay, so yeah. So this was a question, and these are the screenshots of what we did so far. This is how we define. Then you use the fill option to fill in the values, and the other option was to use the Euler's function. In Euler's function, that's how you get these values. Okay, now next, when you like to close a file, you will see this prompt. Do you want to save unsaved document? You may say yes, you may say no. If you want to use it for later, or if you like to show it to your students, or if you're doing it in the exam, when the student doing in the exam, if they like to cross check, they may like to save it. So if they save it, if you say yes, save, then again, there will be a prompt here. Where would you like to save it? So if I zoom into this part, it looks like this. Save Tns File document, Euler's method. Where would you like to save? So you can save this in your computer, your handheld, or you can save it in your desktop, I mean your laptop, right? So when you save this one, if you see, this is .tns file. So this is how it will look. Euler's method differential equation .tns. Okay. Now, what exactly is this? So I'll request my colleague Greta to please discuss more in detail about this. So
Yeah.
may I request Greta, please, to
Sure.
take over. I'll stop sharing my screen and
Yes,
let
correct.
her share her screen and her expertise.
Yes, Chalit.
Where is it? One moment. Yeah, let me see. Where is this?
So while we discussed TNS files and how to put it into press to test, since you're already in the flow of the paper, I thought let me just continue with the paper and I'll get back to the TNS file. Would that be okay?
Wonderful. I'm okay with
yeah.
everything.
So thank you for three different methods. Thank you for 3 different methods of Euler's method. Yeah. Can you see my screen?
Yeah.
Yes. So we move on now to MAA paper 2, the 18 marker. You might not use the calculator at all points in time, but maybe some points in time. So it's good to have it handy. So this is a tip Hassan gave us while we were discussing. So if you want to have it with you by the side, you can always use your emulator in this form. So you have 3 options here. You can just press handheld only and tick mark always in front so that it's with you always in front. All right. Coming to the question, a function f defined by f of x is equal to this. Participants, I hope you can see the question. Now, the region enclosed by the graph y is equal to f of x, the x-axis, the y-axis, and the line x equal to ln 16 is rotated 360 degrees above the x-axis to form a solid of revolution. This is luckily a show that question. So there's no much, room for error. So show that the volume of the solid formed is this. I have kept it ready for you. So if you are working with me, go ahead and put this part. We often observe that our students miss out this beautiful square here, and then everything becomes a mess. So don't forget the square. And if you continue in that form, of course, I've not shown you the steps of substitution. This is required, but go ahead, try it out, and you will arrive at your value. Okay. Chalat, all well, all fine till here?
Yep, looks great.
Looks good. So we arrive at our value of 15k square pi by 34, right? So since that's a show that, I'm sure all of us will easily be able to show that for 6 marks, and the job is done. Next, moving on to Pedro wants to make a small bowl with a volume of 300 centimeter cube based on the result from part A, right? So Pedro's design is shown here. The vertical height of the bowl, BO, is measured along the x-axis. The radius of the bowl stop is OA, and so on. All right. Hassan, have you shared the question with the participants?
Yeah, it has
yes,
been
Rita,
shared.
I've shared in the chat.
Fantastic. Yes. So find the value of K that satisfies the requirements of Pedro's design. So when you're finding K now here, you know that you will have to equate the volume that you find here, right, to 300 and accordingly solve. So if you can see my handheld here, I have already done it for you. I'm happy to do it again. Let me just move on to the other mode so that you can see it clearly. Okay. So you can use your nsolve and proceed. Okay. So equate 300 to the value that was given. Of course, I'm not calling it K because it's nsolve, I'm calling it N. put a comma, put n, take care of the arguments, and your job is done. So 14.7123, if you want to leave it in the exact form, you can go ahead and do so, but this is a paper 2, so I think you will need to round it off to 3 significant figures. Right? Moving on. So we've completed that. Does anybody needs details of this part? Okay. Good. All right. Next, find OA. So when you're finding OA, right, you need to find OA. So that part is actually easily done when in your calculator, if you see here below, I have chosen to define f of x as a function. Okay, now how you do that? You just say f, okay, go on here, hit on f, open the parentheses of x, close the parentheses, and then go ahead and use control and this little template here that is below the delete key or next to the catalog key or next to the Bible key as we refer to it, right? Hit it there, and once you have pressed enter, you will see done. Okay. Now, in order to find the first part, that is, in order to find OA, right? So are you able to arrive at an answer for OA? That means you should say f of 0 in order to find OA, right? So you can just call your function here and 0, or if you want, I mean, it's always advisable to teach students to put it in the form of, where you can call out functions. Am I right, John Paul? I know you stress a lot on, using this feature of functions as them being stored.
Can you repeat that? What did you say? Are you asking students to?
Store it as functions, and then you can call it at any point in time, right?
Yeah,
and then refer to it as a graph and
yeah, absolutely.
So f of 0, then you can go ahead and type it in, right? And you will see that your answer is 7.3, blah, blah, blah. And you can go ahead and round it off. All right. Next, moving on. You now have to find BC, right? So in order to find BC, okay, you know that BC can be found only when the x value there is ln 16, right? So go ahead and put that value into your calculator, type it out, and check and see what you get. That means what I'm asking you to do is take this part, okay? And in place of x, put ln 16, right? And you should arrive at your answer. Yeah. So there you go. Ln 16. There. Hit enter. That's your value, right? And you can go ahead and round that off. Next, for design purposes, Pedro investigates how the cross-sectional radius of the bowl changes. So by sketching the graph of a suitable derivative of f, find where the cross-sectional radius of the bowl is decreasing most rapidly. Go ahead and feel free to graph the derivative of the function here. So you can also, do control a page, because the function is already defined and you will see it getting sketched. Okay, I've already kept it ready for you. And you will see that at the value 1.76, you will observe that this happens. All right. Feel free to do it with me. Next. Okay.
Greta, there is one before you move ahead. There is one question like we can
Yes.
also put when you copy and pasted the values of the function and you change the value of x to ln 16. There was one comment like we can directly put f of ln 16 and directly get the answers.
Oh, yeah,
Yes,
of course.
yes,
we
yes,
can.
yes, of course. I was just showing, sometimes the students like to crudely do it.
Mhm.
You mean this, right? So I
Yeah,
just go here and I type it.
that is why we define it. The one that
Yeah.
you assigned it, and that's why you can use a function. That she's right. Shada's right.
So this is what you were saying, right? I was just showing another format of what we did. Yeah. Thank you for that, participants. There you go. Correct. All right. And then state the cross-sectional radius of the bowl at this point. Go ahead
Greta,
and find.
one more thing. Sorry
Yeah.
to interrupt you. In
Not
this
at all.
D1, when they find the point where it is so decreasing most rapidly.
Yes.
So for the discussion, since this is paper 2, so students are encouraged to use calculators, see the minimum point, but in the classroom, we can continue and extend the discussion to the point of inflection here.
Definitely. Certainly.
Yeah.
Yeah, that's a good point, Jalaj. I was thinking in those terms, but then from an exam point of view, the attempt is to get
Exactly.
to the
Yeah.
answer the quickest and in least possible errors. Yeah.
Yeah.
So moving on to your final answer. So you would put f of 1.76 in order to arrive at your final bit of your answer, right? So I think, Jalaj, I took much lesser time for 18 marks in comparison to the 6 marks that you did. Of course, you did it in 3
You're
different.
brilliant. I'm still learning.
Okay. So no, this question is comparatively easier and I've done it in only one method. That's the reason. Okay. Now moving on to TNS files. Okay. As a teacher, I'd often struggle with, making classes interesting, interactive, and I'd always learn from my colleagues, some of whom are here. So, when it comes to TNS files, right, I'd say it's the smartest way to use and adapt to resources. So you can go on to content here. Okay. I'd love for each of you, if you're using your emulator, please move on to content. Okay. So once you're in your content, hit Math Inspired. Now, if you are fortunate and lucky enough to connect your handheld device to your system, please go ahead and do so. And you will see a small tab here. Okay. Unfortunately, my device is in school. But please go ahead and connect it so you can see and you can drop off those files anytime into your system, into your student system, and make the session even more interactive. That is an amazing feature of TI because you, in one click, you can have a docking station with you, and in a fraction of a second, all the files move into your students' handheld devices as well. All right. So open up any that you like. Open up any that you like from here. So let's say I'm trying out, okay, let's just see, right click on absolutely TNS.tns. Go ahead and open that. All right. And you can see that there are already some activities here for you. Use this. Classroom becomes much more interactive. Not happy with this? Go on to maxima, minima, or continuity, differentiability. So many others. In fact, I'd like for each of you to try, and if you can post in chat which one you are finding interesting. Jalaj, John, I'd love for you to tell me your favorites as well.
I learned something new today. I already told Hassan. I'll comment about that later on, but continue. This is interesting. I'll talk about what I learned later.
John, you learned from me or you learned from Jalaj?
Yeah. No. I learned something new. I'll talk about it later.
Okay, good. Yeah. So maximas, minimums, and zeros. Okay. There you go. Ready to use. One-stop shop. There you go. Okay. 2.2. Come on, participants. I'd encourage you. Try it out. Tell me your favorite TNS files. Okay. Now, since we're talking about TI in assessments, right? And we've already covered, this .tns. So my first question to Hassan was, Hassan, what is the full form of TNS? And I went on thinking, is it linked to Oracle? Is it linked to this? And then I found that, it's just a calculator program created for TI Nspire handheld graphing calculators that can include graphs, statistical data, and so on. Okay, so this is the full form for some of you who like to associate terminology with what you do. Okay, Hassan, are we getting any answers? Jalaj, are we getting any answers?
Not yet. You can continue.
Yeah. Have you dropped in the TNS files for the participants?
Okay, I'll do that. I'll share the Google link where I have attached many TNS files so that they can explore.
Fantastic. Thank you, Hassan. So participants, you can also take it from where Hassan is dropping it from. Okay, and another nice thing that I like, is quick fixes that make classroom sessions really interesting. And because the session is about assessments, especially if you're an MYP school and you have to focus on the Criterion D tasks, where students have to think and relate to real life applications. I like this feature wherein you can go ahead and insert images. So this was one that I learned from somebody else, wherein you can go ahead and place like a clover leaf. And I remember doing this in my class, and I also celebrated St. Patrick's Day somewhere in March, wherein the D1, that is the grade 11s, kind of inserted points. We did this with leaves, and we were lucky to be face to face. So we did this with leaves. Actually, I should do it on Doc 41. Hang on, Doc 41, call a new page. Okay, you can add graphs if you like. Go ahead, insert image, call whatever image you like. You can, I like to do it with rangolis and diyas, different kinds of patterns. You can use it even for modulo graphing to see the pattern that is generated. Now, different things you can teach here: domain, range. You can associate by just through a leaf. And you go ahead and put out points. You can capture the points. You can take it to lists, right? And from here you can develop a whole lesson, and or you can develop a whole assessment. So I also remember assessing my students by doing a viva for some of them with modulus functions, wherein I showed them rooftops and I asked them to generate the graph for the rooftop that I gave them. So it had functions associated with it, and it had transformations of functions associated with it. Okay, and the last thing that I want to show you very quickly before we move on to paper 3 is when you prepare your handheld for press to test. Now, in some schools where numbers are large, putting into press to test becomes a small concern. So it's nice to have your device ready. Okay, so you can go to prepare handhelds. All right. Then you can go to send press to test, choose press to test restrictions. So, if you're having an IGCSE exam, accordingly, the settings will change. If you're having an IB exam, go ahead, save it here, call it IB press to test so that that these are the ones that need to be enabled, and these are the ones that need to be disabled. Save it in whatever name you want to give it, save it here. And whenever, you can go ahead, Greta IB, or you want to disable a particular feature just to see if students understood a particular assessment, go ahead and do that and say, yes, go ahead and say yes and save it. And you can always go back and save it again. Hassan will also share with you the press to test document, which addresses press to test, reset press to test, and repress to test. Thank you. Over to you, Jalaj.
Great. Thank you so much, Greta. There's so many things we all learned. And John, would you like to share what did you learn? You wanted to share something?
Oh no, that's got nothing to do with the calculator. But I did not know ln of x is also referred to as lawn, LAWN. That is something. I mean, it completely blew my mind. I immediately went and checked out online, and yeah, so I learned something new there of the content. However,
John,
I wanted to just.
I was referring to natural logs, by the way.
Yeah. I know. That's why I said ln of log. I said that's something new I learned. Okay, I did not know about it, to be very honest. Okay. Mm-hmm. But what I wanted to add was this option that she just showed about the inserting the image. I just put it on the chat that it's only available on the software, not on the handheld. So encourage kids to use the software as well. Normally, whenever I've encountered students from different schools also, they say that they did not know that there was a software that is available to them. So perhaps it's a good time to let all the participants here, all the teachers know that when the students get their calculators, let them know that there is a software also available, because normally when they get the calculator, they just open the box and they're happy and they throw the box away. They forget that there is a serial a number available which they can activate after downloading the software, and to use that in combination for such great activities that are available. Also, when they need to upgrade their software, again, that's another thing that many of the students that I've encountered when I'm tutoring or when I'm meeting in some workshops or webinars, they didn't know that there's an operating system for their handheld that needs to be regularly updated. But the only way to do it is when you link it to the software. So please encourage students to use the software for all these activities and to update the software. That I thought I'll make that comment.
Lovely. Thanks, John. Thank you so much. Okay, so once again, thanks, Greta. It was really wonderful to see like how effectively can we work using a graphic calculator during any assessment, whether it's final IB assessment or usual formatives or summative, internal summative assessment. It is always very, very helpful. Now, even in the calculator paper, you will encounter some questions where use of calculator is neutral, and sometimes it's difficult to use calculator. So that's okay to not to use calculator in every question of paper 2 and paper 3 of MAA or all 3 papers of MAI. This is very much okay. Like in paper 3, if you see in May 21, there were 2 questions in MAA. In one of the questions, it was almost impossible to solve the question or attempt the question rather without a calculator. That was question number 1. And in another question, it was not very easy to use the calculator because there were no numbers in that question, and everything was actually based on geometry. It was more of like an application of mensuration, geometry, and some trigonometry. So let's explore that question. And if you all could go to that link which Hassan shared just now, and in that link, I think it's question number 3. This is question number 3, and it is second question of MAA paper 3 of May 21. It's a long question, so I'm not showing it to you on the screen. So you can just have a look at that. And before that, let me share my screen. Yeah, Hassan has just shared this once more. So please open the paper. And let me share my screen and go to my, oops, where I am. Is it here in my canvas? Yes, I'm in my canvas once again. So let's get started, and let me also open that question so that we are on the same page. Give me a sec, please. This is no. My God, I can't find where it is. Sorry for this delay, May 21. No, I think I have to use Hassan's link here. Not this one. Not this one. Not this one. One sec, guys.
Chalet, if you like, I can quickly share my screen and you can take a snapshot of it.
No, that's okay. It's
right.
here. It's right here. One moment, yeah. Yeah. Yeah, I got it. Thanks. Okay, so quickly reading this question. This was total 314.
28 marks.
28 marks worth question. And this is basically investigation. The question asks you to examine various polygons for which the numerical value of area is same as the numerical value of the perimeter. For example, a 3 by 6 rectangle has an area of 18 and a perimeter of 18. For each polygon in this question, let the numerical value of area be capital A and let the numerical value of its perimeter be capital P. So let's start solving this question. And this is a very interesting question where we explore the relation in perimeter and area of different polygons and see how polygons change when the number of sides change, what are the changes that this undergoes, and so on and so forth. Okay, so part A of the question, find the for each polygon in this question, let the numerical value of its area is capital A and let the numerical value of its perimeter be B. Part A, find the side length S, where S is positive of a square such that area and perimeter are equal. So in part A, this is a square. So let's quickly, I always ask my students to visualize what they're doing. As and when they get any chance of visualizing, sketching, drawing, they must do. So in this question, there is a square whose side length is small s, and it says that area and perimeter are equal. So area of this square will be side times side, so s squared, and perimeter is 4 times s. So s squared minus 4s is equal to 0. And this gives you s is equal to 0 or s is equal to 4. Now, if you go back and read the question, it says s is positive. S is more than 0. So since s is more than 0, so the value of s is 4 here. This is part A of the question. Now, in part B, an n-sided regular polygon can be divided into n congruent isosceles triangles. Let x be the length of each of the two equal sides of one such isosceles triangle and y be the length of the third side. The included angle between the two equal sides has magnitude 2 pi upon n. Part of such an n-sided regular polygon is shown in the following diagram. So there's a diagram, and in that diagram, we need to capture only the triangular part of it. So keeping in the same orientation, if I see, so your triangle will look like something like this, where this is x, this is x, this is y, and this angle is 2 pi upon n. 2 pi divided by n. So let's go back to the question. A part of such this is given, fine. Part B. Part B says write down in terms of x and n an expression for the area AT of one of these isosceles triangles. So we can use simple that half AB sine C, that which is derived from sine rule. So area of this triangle will be A is equal to half two sides times sine of the included angle. So you get half x squared and sine of 2 pi upon n. And this is AT, because we are using A also, and this is AT given. So be careful, don't mix AT and A. This is 1 mark question. Obviously, it can't have more than 1 mark worth. Part C. Part C of the question is show that y is equal to 2x sine pi upon n. This is 2 marks question. So to find y this triangle, there are so many different ways we can solve this into. Either we can draw, since it is an isosceles triangle, so if you draw a perpendicular, it will divide this into 2 parts. You may use sine rule, you can use cosine rule, you can use Pythagoras theorem. So the simplest way out here, which I can see, is to use simple trigonometric ratio of sine, SOHCAHTOA. So if you find this is the entire angle is 2 pi upon n. So these you will get, when you draw perpendicular, you will get two congruent triangles. So this angle will be sine half of 2 pi upon n, that is pi by n. So sine of pi upon n is opposite over hypotenuse. So y upon 2 divided by x, which is equal to y divided by 2x. So the question is asking you to show that y is equal to something. So y is equal to 2x sine pi upon n. So this is what we are supposed to do. This was also a 2 marks question. Moving on. Oh, next with 7 marks question. Consider a n-sided regular polygon such that area is equal to perimeter. Use your results from part B and C to show that area is equal to perimeter is equal to 4 and tangent of pi upon n. It is a 7 marks question. Okay, so there is an n-sided polygon, and if you refer to the diagram, that polygon will have sides, n sides, since it's n-sided polygon, and length of each side is y. And this is n-sided regular polygon, so ny will be the perimeter, and area will be n times area of one triangle, right? So the question is asking us to use part B and part C, means area of triangle and value of y. So we will use area of triangle and value of y, no problem, and we can solve it quickly. Okay, for n-sided regular polygon, what will be the area? Area will be n times area of triangle. Should we name this triangle, or since we already have 80, so let's not write area of triangle. Let's just write 80, and its perimeter, since it is a regular polygon, so each side will be y, so n times y. So this is the area and this is the perimeter. Now, area and perimeter both are equal. So also we have a value of y. So can we write it n times 2x sine pi upon n? And this will be n times 80. We found from part B is half x squared sine x squared sine 2 pi upon n. So this is sine 2 pi upon n. So let's equate these two and see what do we get. Because the question says again, use your results from part B and C to show that area is equal to perimeter is equal to this thing 4n tan pi upon n. Now if you look at this, area and perimeter is equal to 4n tangent of pi upon n. There is no x value there, and the angle is not 2 pi upon n. The angle is pi upon n. So the first thing, or line of like thoughts could be, first thing we need to do is we need to eliminate x value, and second thing is this sine 2 pi upon n should be expressed as sine pi upon n. So let's do these two things first and see where does this take us. So when area is equal to perimeter, so we can say since area is equal to perimeter, so this will be n upon 2 x squared sine 2 pi upon n is equal to 2nx sine pi upon n. Now in the like we need to prove area and perimeter is equal to 4 and tan pi upon n. I'm repeating this again and again. So n we can cancel because n cannot be 0. Since n cannot be 0, so n can be cancelled. So this will give you now the sine 2 pi upon n. We don't need this because we need pi upon n. So can we write this as x squared upon 2 if we use double angle formula? So sine 2 theta is 2 sine theta cos theta. So this will be 2 sine pi upon n cosine of pi upon n is equal to 2x sine pi upon n. And this will be, can we bring everything to one side? So this will be, wait, let me see. Okay, first what we can do is we can cancel 2's. So x squared sine pi by n. So it will be x squared sine pi by n cos pi by n. So this will become x squared sine pi by n cos pi by n minus 2x sine pi by n is equal to 0, right? So can we take anything common here? We can take x sine pi upon n common. So you get x cos pi upon n minus 2 is equal to 0. Now x is one of the sides, so it cannot be 0. One more. It's getting dark here, so I just turned on the light. Okay, so x cannot be 0, sine pi upon n cannot be 0 since x is not 0. So from here, what do we get is value of x, that is 2 over cos pi upon n. X is equal to, yeah, 2 over cos pi upon n. Looks good. So if we go back and see what was the area, what was the perimeter. So what was the perimeter? Perimeter was n times y. And y was 2x sine pi by n. So n times 2x sine pi by n. So if you put the value of x from here, your perimeter will be n times 2, and 2 is 4 over cos pi over n times sine pi over n. So finally the value of p or a, because they're both given equal, will be 4n sine pi over n upon cos pi over n is 10 pi over n. Wow, finally we got it. So this was 7 marks question. So this is area or perimeter, which is this much. This was part D of the question. Now we have how many more parts? Oh, we have a few more parts. Okay, moving on quickly. The Maclaurin series for 10x is this much. Use the Maclaurin series for 10x to find the value of this. Okay, so I think I need to go and change my page here because it's full. So I'll open a new page. Part E. Use the Maclaurin series for 10x to work out this one. We know that E. The Maclaurin series for 10 is x plus x cube over 3 plus 2 over 15x raised to the power of 5 plus and so on so forth. You need to find a limit n tends to infinity for n tan pi upon n. So for n tan pi upon n. So when limit n tends to infinity, so can we say this is limit n tends to infinity and for n times. Maclaurin series for tangent is x plus x cube over 3. So this will be pi over n plus 1/3 pi cube over n cube plus 2 over 15 pi raised to the power of 5 over n raised to the power of 5 plus and so on so forth. Now when you multiply this with 4n, limit n tends to infinity, and 4 pi plus 4 upon 3 pi cube. My apology if my pi and n are looking similar. Upon n squared. Is it n squared? Yes. Plus 4 times 2 is 8 upon 15 pi raised to the power of 4 or 5 over n raised to the power of 4 plus and so on so forth. Now, when limit n tends to infinity, what happens to 1 upon n? When n tends to infinity, 1 upon n tends to 0. So in this case, your expression will be 4 pi plus, because all those terms have n cube, n squared, and 4 and so on. So this is n 4. So to find this, I think that's all we need to do here. This is a 3 marks question. We have done enough work for 3 marks. Part 2. Part 2 is to interpret your answer to part E geometrically. Now, if you see geometrically, what is happening here? For n, I think we need to go back and look for what was the area. In the previous part, our area was, if you see, area or perimeter was 4n tangent of pi upon n, right? This was the area or perimeter that we calculated. This was area of an n-sided regular polygon. And when n tends to infinity, what happens? When size increases, triangle becomes quadrilateral, pentagon, hexagon, and so on and so forth. And when it keeps increasing, will it become a circle? It will become a circle, right? So as n tends to infinity, polygon tends to be a circle. So when it is a circle, then its area or perimeter is equal to 4 pi. Area, let's say its radius is r, so pi r squared. When pi r squared is equal to 4 pi, r is equal to 2. And when you look at the perimeter, perimeter is circumference. So when 2 pi r is equal to 4 pi, r is equal to 2. So interpret your answer to part A geometrically. So what happens geometrically? When n tends to infinity, your polygon will become a circle of radius 2 centimeter. Right? Moving on, consider a right angle triangle with side length a, b, and square root of a squared plus b squared, where a is more than b and area and perimeter are equal. Okay, part E, this is part F. Then show that part F. So again, try to visualize this. A is more than b. So let's say this is a, this is b, and this is the square root of a squared plus b squared. So consider a right triangle with these side lengths. Show that area, when area and perimeter are equal, this thing happens. So its area we can say is half a times b, and perimeter is a plus b plus square root of a squared plus b squared. I think you can do this. This shouldn't be difficult. Wow, this is again 7 marks question. Okay, let's try this. Let's do this. So just multiply with 2. So AB is equal to 2A plus 2B plus 2 square root of a squared plus b squared. We do not have any square root in the final answer when what we are showing. So we need to get rid of this. So let's make it subject to formula. So 2 square root of a squared plus b squared is equal to ab minus 2a minus 2b. If you square both sides, you get 4 times a squared plus b squared is equal to 3 terms. When squared, you get square of first term. So a square b squared plus the square of second term plus square of third term plus 2 times first and second term. So you get minus 4a squared b plus 4ab. No, 8ab. 2 times this. Okay. And first and third will be 2 minus 2ab squared. So minus 4ab squared. Now out here, if you see 4a squared and 4b squared, you can cancel with your left hand side. So what we have is a square b square minus, okay, so what we have here is a square b square minus 4a square b minus 4a square b plus 8ab plus 8ab minus 4ab squared is equal to 0. So can we take anything common here? I think we can take ab common. So we get ab minus 4a plus 8 minus 4b is equal to 0. Now a, b are sides, it cannot be 0, means your bracket can be 0. So ab minus 4a plus 8 minus 4b is equal to 0. Now when we look at the question once more, it says show that a is equal to something. So you have to put both a's together. So when I take a common, you get b minus 4 is equal to 4b minus 8. So a is equal to 4b minus 8 over b minus 4. Right? So you have, okay, there is no a or b in the numerator. Fine. So can we write it as 4 times b minus 4? So this gives you 4b minus 16 minus 8. So plus 8 upon b minus 4. So finally, a is equal to 4 divided by b minus, no, b minus 4 are gone actually. So you get 4 plus 8 divided by b minus 4. This is what we are supposed to prove here in this part of the question. Wow, this was also 7 marks question. Part G, last part. Okay, by using the results of part F or otherwise, determine the 3 side lengths of only 2 right angle triangle for which A, B, AP all are integers. Great. This we can check. Now, A, B, A, capital P, all are integers. And this is part G. I'm sure they all are connected, related to each other. A and B, both are integers. Capital A is integer, perimeter is also integer. So if you go back and see, for area to be integer, A and B both should be integer because area was half AB. And for perimeter to be integer, square root of A squared plus B squared should also be an integer. So A should be an integer, B should be an integer, square root of A squared plus B squared should be an integer. Means when A and B are squared and added, we should get a perfect square. Another information we have is A is equal to 8 over B minus 4 plus B. It means this 8 over B minus 4, this should be an integer because A is equal to this much plus 8. So for this to be an integer, B minus 4 should be a factor of 8, right? So let's, okay, another thing is A is more than B. So B minus 4 cannot be negative, right? If this happens, then A has to be less than B. Okay, so considering all these, let's start. Can B be 0? No. Can B be 1? No. 2, 3, 4? No. If this happens, then A will have less value. It should be a multiple. So let's start from 5. What if b is equal to 5? Then what happens? I think in this question you have to just use trial and error. So when b is equal to 5, what is the value of a? 5 minus 4 is 1. 8 plus 8, 5. When b is 5, a is equal to, what is a? 5 minus 4 is 1. So 8, 8 and 8, 16.
Jalaj, as rightly pointed out by Shraddha Nayak, I think that A is equal to 8 upon B minus 4, it's plus 4, right? From
Is
the
it?
previous?
Is it plus
In
4?
your final step, see your final step, A is equal to 4 plus 8, right? So you have written plus 8 over here, right? Am I thinking incorrect or?
No, that's right. That's right.
Yeah.
Oh,
yeah.
yes.
Shraddha's also pointed it.
Thanks, Shraddha. Thank you so much.
Yeah,
I was thinking where we are going wrong. So it's.
Yeah, Mary Kim has also pointed it. Yeah.
Yeah.
Is this
Thank you so-
just one? Is this Marie Kim, the same Marie Kim from Cinemas?
She can't say yes or no. She'll have to type to you.
Yes, I invited her.
Oh wow, good to see you here. I'll say hi to her later, maybe. Yeah.
Yes. We can continue, Jalaj. Yeah.
Okay. So when b is equal to 5, 4 upon 1 is 4 plus 8, 12. So a is equal to 12. And what is the square root of a squared plus
It's supposed to be plus 4, right, Jalaj? Plus 4, not plus 8. Isn't
Where?
it? In your expression here. In the
In the expression of A,
I'll annotate it here.
should be
This
plus
is
4
supposed
here.
to be plus 4.
Hold on. I think I need to go back and check.
Here,
plus,
see?
Yeah.
I'm annotating it for you. So this has to be plus 4 here.
I agree. So we are not very far from the truth. I just have to erase just 2 terms here. Okay. So going back, a and b both should be integer. Square root of when you take a squared and b squared, it should be a perfect square. So just copying it down again. Oh my God, how can I copy incorrectly? 8 upon b minus 4.
Plus 4.
Plus 4. Thank you.
Correct.
Okay, so going back, other things are same. So when b is equal to 5, when b is equal to 5, so 5 minus 4 is 1, so 8 plus, please correct me if I'm wrong, is a is equal to 12? Yes, it seems now things are in order. So a squared plus b squared will be 5 squared plus 12 squared, that is 30. Yep. Which is a perfect 13 squared, right? 169. It is a typical Pythagorean triplet. So 5, 12, and 30. So a should be 12 and b should be 5. Okay, now let's move on. What if b is equal to 6? We are just doing it by trial and error. So when b is 6, 6 minus 4 is 2, 8 upon 2 is 4, 4 plus 4 is 8. So b is 6, so a is equal to 8. And a squared plus b squared will be 6 squared is 36 plus 6400, which is 10 squared. Perfect. So that's all I think we need to do in this question. If we read the question again, by using the result of part F or otherwise, determine the 3 side lengths of only 2 right angle triangle for which A, B, capital A, capital P all are integers. Wonderful, it's all done. Then determine the area and perimeter of 2 right angle triangle. So area and perimeter both will be same. So I can show it in this corner instead of moving to a new page. So area and perimeter. For the first one, when A is 12 and B is 5, so 5 plus 12 plus 13 is 30 in the first case, and in the second case, area and perimeter, this will be 6, 8, 10, that is 24. I think that's all. So this is how we can solve. Now, if you see in this question, we had limited scope of using calculator. Other than like routine calculations, there was not much of the scope. But in the other question, which is the first question of same paper, without calculator, you can't even think of doing this. We did this, I think 2 weeks back, we solved it in one of our webinars. So I'm sure recording must be available. So you can have a look.
Jalaj, can you check that the values of A and P? What does it add up to? Is it 30? Mrs. Naik just pointed it out for the second.
30, not 30, sorry, 30, 30. Thanks, Shraddha. 30. This is 5, 12, and 13. So 25 plus 5 is 30. And when we use 6, 6 and 8, 14 and 10, 24. Thanks. Thanks, John. Thanks, Shraddha. So here I stop. And Greta, if you have anything else to share, please go ahead. I'm stopping here. So I stop to share. And
before Greta goes, can we take questions from the participants if they have any question, any doubt, anything they want to ask related to the question what Jalaj has done? You can even raise your hand, or we can unmute you and you can speak if you want.
Thank you, Rita, and thank you, Jalaj. Thank you all for joining with us today. I think all the participants would have enjoyed the session today. It's really a very informative session for the TI users especially. And we will definitely share the recordings of this webinar to all the participants, because we've been getting requests from the participants who are leaving early that they want the session recordings. Yes, sure, we'll be sharing that. And yes, and if anyone have questions, they can raise their hands. We can unmute you.
No, it is. Mrs. Naik just asked about the Chrome app. You know, Jalaj, you want to talk about that?
Yeah, it's in. Yeah, it's one of the apps of Chrome only, but it opens in like a new tab. It is not add-on. So. Yeah. And it's free, so feel free to use it.
Yeah.
And there is one more question from, I don't know.
Thank you, Aparna, for the comment.
Ranganathan asked, like, we requested IB to reduce the number of subdivision. Any update on that?
Subdivisions of what?
Subdivisions of
IB questions.
Larger questions.
Achha, yeah, the longer questions. Yeah, that you wrote to them saying shorten it. I don't know. I mean, I know that sometimes it just goes longer, but I think there is the 24, and to meet that marks, they try and, I think it's paper 3 idea that they keep it that long. So that's the reason. I'm not sure whether. In the IB workshop, yeah, no response as yet. So we'll have to wait on that. Solving questions based on TI Nspire. Absolutely. Puri, though she says, yeah.
Hasan, can you unmute Mrs. Shraddha?
Yeah, now she can.
Hi everyone.
Ma'am.
Yeah, I'm. Can I be heard?
Yep.
Yes.
Go ahead.
I think the subdivisions really help with scaffolding. You know, one of the approaches that IB uses, from my experience, is that it gives a more room for thinking and for approaching questions if there is scaffolding. So I think that's my perspective.
No, true. Scaffolding, that's the reason they have, even the preparation from something like an IGCSE paper 6 and all. But, when it goes up to like G and H for more than, sometimes it's good. Of course, that's the idea. But, my point was that because you have to account for something like a 24 or even a 30 points at that point of time, then you need multiple questions. You can't have, like, even though the questions that Jalaj is solving today, some are out of 7 each, so some of the subdivisions. So those were all scaffolded, but still to then account for something like a 24 plus, then you will have so many subparts anyway.
Yeah, true.
Because you can only have 2 questions, right, in that paper 3, 2 main questions.
2
Yeah.
questions.
And so then, yeah. But yeah, it was great, Jalaj, and I'm so happy to see Marie Kim. I never knew that I'd see her in a TI webinar like this. I don't know whether she remembers me. I was there for that WMC. I'll have to write to her. I have a number. I'll write to her later. But very good to see her. Yeah.
Jalaj and Greta, great presentations. Loved the working and loved every bit of it.
Lovely to see you.
Hi, Mary. Thank you so much for
Hi,
joining.
hi. It was so nice. I'm so happy to see all this discussion and nice feature of like TI Inspire. Like I learned something new today.
Very good. And for those of you who don't know Marie, I was there for this competition in Indonesia. I think she's the most vibrant. I'm so much energy.
Oh my God, you are calling me a vicious person?
I never said anything like that. I said so much energy. I never said anything like that. But she was even helpful after the thing because I think
no, I'm teasing you. Yeah.
But both she and her husband, they used to hang out till late that evening, taking care of all the participants. But so much energy that they had in going to organizing such a wonderful competition. Fantastic to see here, Marie, and give my regards to your husband also.
Oh, I'm so glad to see you.
Yeah.
Any other question, any query from participants before?
Yeah, one asked, like, can someone share the grade boundaries for AA, HL, and SL? Tentative is also fine.
Yes, we can. It is, I think, for 2020, it's already on my IB. If you go to Program Resource Center, it's already there. But I can share with you, Hassan, and if you could, it's great.
Yeah, I will share with the participants.
Yeah. May 20 is participant asking for May 20 boundaries.
Yeah, the most recent, of course. Yeah.
Okay, so
maybe even for AI, because there are other teachers also. So if you're sharing,
okay. I'm sharing with Hassan the document which is boundaries of all the subjects, all the levels. So you just choose yours and you can ignore other. Hassan here. Hassan, yeah, please.
They weren't available for May 20, right?
Yes, May 20.
Yeah, that's what I thought.
Yeah. It is May 20, and Hassan, I just sent you. Can you check if you got it?
You have sent me through mail?
No, I just sent it through WhatsApp.
Oh.
Is it okay, WhatsApp, or should I mail it to you?
No issues. Yeah, I think I got it.
It's May 20, grade boundaries. So I don't know if I can drop here this in the chat also as an attachment.
Okay, I'll just share in the chat the link, and I'll also mail them.
And there is a request from one Mr. Ramesh asking maybe expect other workshops like this. Yes, definitely, Mr. Ramesh. Every Saturdays we are having these webinars between 3 to 5 in different topics. We'll keep you posted about the webinar at least 3 days before. So you can register and you'll get the Zoom link a day before the webinar and you can join. Yes, we are conducting webinar every Saturdays between 3 to 5. Teachers can also write to us if they have any special request on any topics that they wanted us to address. You can write to us. You can make a note of our email IDs. Hassan, can you display our email IDs in the screen?
Yeah. And one more question, ma'am. I have unmuted you. You can speak. You can unmute yourself and you can speak.
About internal assessment exploration, is it advisable to avoid the statistics topics for AA? No. Any topic that fits well into the criteria you can choose, and there are some like frequently done topics like in stats. If you see, collecting data, checking the trend. So if the student can personalize those, like this is my opinion. So of course, Shraddha, Greta, John will also uh, give theirs. So any topic where a student can personalize what they are doing, if they can customize it, and if they can meet the criteria, they're most
What is the
welcome to go ahead.
what is the question about? Like, is it
The-
an IA thing?
So the
About
question, yeah.
IA, the question was regarding internal assessment. Is it advisable to avoid statistics topics for AA?
So Jalaj, what I
Not
think
really.
here, what I think here is, it also depends. Like if it's an AA, the dependency on functions will be more. Function and statistics make an awesome combination in AA.
Absolutely. Absolutely.
There is one more question. If you can take up that in the chat, you can see.
Hasan, can you unmute Ms.
Yeah.
Mansi Grover? Yeah.
Yeah, Miss Mansi, you can speak.
Hi, good evening, everyone, and thank you so much for the session. It is really helpful. There's one question. I mean, this year, luckily or unluckily, we didn't have the exam, but we really faced difficulty in completing the syllabus for AIHL. I just wanted to ask if it's the same scenario in your school, or maybe the people from other parts of the world can also tell, and maybe there's something, any suggestions you want to throw away.
Can this is a great question. In fact, if you can just hold on to this question,
Sure.
because we'd like to do one session only on this topic of the online, because now all of us in India, every teacher, whether they're an IB or not IB or not international and national, everyone can say we have 1 year experience in online education, right?
Yeah.
So
1.5 years.
Whatever that is. Jalaj believes in accuracy. I believe in rounding off. What we'd like to have a webinar on how effective was it, and how do we define effectiveness? And that day we'd like to actually invite even students and parents. So let's just keep it open, because it's not just about completing syllabus, but it's also about considering mental health. It's also talking about what is just education? It is just information.
Right.
And so, I mean, if you can just hold, because it's a larger topic, because if I get involved, then I'll get very passionate about it. But so just hold on. All right.
All right.
But
So,
we'll answer that.
And just one thing, Mansi, in this one, usually it happens when we do not value their prior knowledge.
right.
If we just take the syllabus and we start completing the syllabus, take first topic done, take second done, take third done, take. There is so much which they already know. So we unnecessarily spoon feed them, and we redo those topics which are not really needed to be done once again. Second thing is, when we don't effectively use the graphic calculator, when you do things manually, it is time consuming.
Right.
So these are two main areas where we need to further discuss. So when John comes back, and we will have a session, as he mentioned, so we will discuss this in detail. But the two basic areas which, like in my opinion, what I have identified is we need to value their prior knowledge, and we do not need to repeat what they already know, and use technology as much as we can.
Right. I totally agree with you, Mr. Jalaj. We underestimate and we try to, spoon feed them. Yeah.
Jalaj, just to add to that, what I feel is,
Great. Go ahead.
what I feel is just to add to that, backward planning in such cases helps, keeping in mind prior knowledge and the technology. So if you backward plan it, I think it definitely fits into that.
Right.
Absolutely. That is actually, as we say, it's the Brahmastra, backward planning. There is no match to that. You just do
But
backward planning.
Jalaj, one comment is there, like the students are from a various background, so
Yes,
they
I
are
agree.
not same. Yeah.
But
One,
if it's Yeah, go ahead, John.
One thing is good is when I think many schools opt for this bridge program. So when they come from a, I think many schools do that, that when a child is coming into an IB, I know that because they come from different backgrounds, whether they come from the national curriculum, some come from, I mean, some fit in really well. But once we have a good enough bridge program, what I mean by good enough is that, we show them, well, these are the requirements. We may not necessarily be able to cover that on our own, but students are well aware of, because I think mostly what happens in the beginning stage is that we are laying down so many foundational things. So if that is clear at the bridge program itself, that what the child is or what the student needs to know as a prior learning, and then we can proceed with that, and then we can assume that everyone is at the same level. Perhaps that is something that Revati, we can consider as a topic for some, like how we are preparing students when they have to make a choice between AA and AI. Many schools start off with a very common during the bridge and maybe a couple of months when the students are making the decision, and there are some common topics, of course, a core at that time. How are we helping students to make that choice between AA and AI? But also, this must, whether they're doing AA or AI, as Jalaj was also talking about, technology. I tell, even in my bridge classes, whenever I've done that, I've always emphasized on the use of technology, because whether they're doing AA or whether they're doing AI, they have to get used to using the calculator, not just as a means of calculations and computation, because till then, if they think of calculator, they think of calculator just as a computation, but as almost like, I tell my students that, make it your friend. Like anything you need to ask, just go and, explore, and, all those small things that they can explore, that they can cross verify their solutions. That if we keep as a stronger emphasis during those early days, those bridge days, I think it'll be a great thing. And like, again, to re-echo what was presented today, the kids will learn and probably, do much faster. We will be surprised at what rate they'll be absorbing.
Exactly. And Hassan, like as you mentioned, they come from different backgrounds, and John talked about the bridge program. Also, if we see like in the syllabus, I mean the subject guides. So in MAI, I'm talking about MAI subject guide, starting from page number 23 onwards, 24. There are like the topics on prior knowledge. So if they come from different backgrounds, maybe school can share with them, this is something expected, this is your prior learning. So when they join the school, new school from a different background, they have exposure to, if they don't have exposure, they can do some self-study to fill in those gaps. And as Mary mentioned here, she says AIHL is more difficult than AAHL. Yeah, I strongly agree with you. AIHL is more demanding.
It is, and I think it's good. It's good that we can have these conversations now, because a year ago or 2 years ago, when the course was just being introduced, many schools. I can only speak for Bombay. Where we've had teachers or students look down upon the course.
Yeah.
I'm serious.
Exactly, same here in my school also.
And hopefully at the end of now that we have some information available, because earlier we just had textbooks. Even textbooks took a long time for textbooks to surface. But now that the papers have come out, now when we start discussing with what is expected, although we still need to have an examination, hopefully my hope and prayer is that respect will be restored. And I'm using the word restored because
restored.
I believe that it was always there. It is just that we have perceived it differently and interpreted it differently.
May I have a few comments, because
yes,
this year I was assigned AIHL IA marking, and after I marked like 100 AIHL IA, I was very disappointed. Honestly, it's because students, I think about like more than half of students, maybe 70% of students, they took statistic, but they did statistic very poorly.
Oh.
Yeah. So like most likely they just like put bunch of like a statistical result and graph, and they didn't really try what does that mean or what does that imply, right?
The interpretation,
yeah, interpretation and implication were seriously lacking, and some students, they even try like multi-level comparison such as app test or something like that, which is way out of their head, and they believe that this might give them like good math criteria E, but in the end they couldn't digest at all, and I could see clearly from their writing, and then end up having really low score. And it was quite like difficult for me marking AIHL, because AIHL IA, it's because like students, both students and teachers, they don't seem to understand what is expected from the course of AIHL. So
here's a tip. Here's one thing that has worked for me, Marie. What I have done is that I have always I learned something from a chemistry teacher, actually. This chemistry teacher who was my colleague. He used to do what he called a mock IA, like not just before that, but he did it in different stages, because I know there are teachers who believe that you need to first teach them the content and then you start giving them, to write the IA. But IA is a skill in itself, like you said. I mean, they need to be able to interpret. So even during a bridge program where they don't know anything, just give them a graph and tell them to write a couple of sentences about it. It may not be perfect, but they have never seen the need to write or to describe with words. So right from an early stage, if some of those skills are deliberately, I use the word deliberately and intentionally. So if we give them those experiences right from the early stage to, there's like, for a homework, you're given a graph, you give the answer. The question is, what do they have to say about it? Comparing two different graphs. Exactly. Exactly. What are the implications? How do they compare it with some other set of data that's happening on? So I think if we can give practice IA also, like, if you don't want to like the word mock IA, because it seems like you're mocking the IA. So if you give them some practice IA, or even in bits, which means, they can, one bit can be about the reflection, bit can be about evaluating it critically. So even that, suddenly when they're writing the final version, many kids have a hard time understanding that. So what I do is that I take the criteria and read those criteria with them when they're looking at each skill, and so those things are sorry.
Yeah. No, you finish, John. I'll comment in after you finished.
So with each skill, when we are presenting with smaller tasks, like I said, it need not be content heavy tasks. But even when it comes to evaluation, if you give them smaller tasks and ask them to comment, ask them to write reflections, and then read that rubric alongside with them and help them to understand what is expected. Then when they come to writing, when they're writing the final version of the IA, they know what is expected. They know what they will be marked on. They can themselves, when they do peer, I've often done peer evaluation also when they in their writing process. They can also comment and say, okay, how much is it? Is it a 3? Is it a 4? They'll be able to say. Anyway, that was just my comment. Yes, Mrs. Nayak.
Yeah. So I tried this with our students. Mini IA is what we call it. Give them an experience in the first year, so around March, so they get an understanding of the criteria, and also peer evaluate. But what I recognized, or what I realized, is that when it comes to their real IA, they somehow think that they've got to use math that they have not been taught before. And when they do that, they miserably fail there, because they cannot explain, they do not understand, and that's what happens. So the mini IA, even if they it gets across to them the criteria, they do understand most of it, but in an effort or in a desire to get good scores, they miss the boat.
I would like to add one more thing.
Sorry, Jalash, you go ahead. I'll talk later. You go ahead.
Just one more thing, like in IAs, what happens is if you don't follow up, they do not do their work consistently. So most of the work they do like maybe a week before their deadline. So what I do is I usually follow up every week, or maybe once, twice, or thrice in a week. I keep reminding them. And another thing is the students, they should take pride in their work. If they do not celebrate what they are doing, if they complete their work just for the sake of completing the internal assessment requirement, they will never do like great.
Totally
great
agree. Totally
IELTS.
agree there.
They have to
I
start celebrating their learning.
I just want to
See,
quickly. This is the
Purvi Doshi wants to say something.
just one. I just want to complete this one point because I was just
Yeah.
talking about the rubric
Go
and
ahead, go ahead.
going back to what Mrs. Naik was just saying. So when I'm doing this, I actually because they sometimes when you give a document to children, you can't expect them to read it. Them to read it on their own. So I highlight certain areas as I've highlighted and I make sure that they've read that and I read that in class with them. So going to that topic thing, Mrs. Naik, which is saying, I make sure that I have when it comes to that level of the I. One sec, let me go to that. So use of mathematics. This is for SL. And use of mathematics, which is for HL out here. At that point, I make sure that they're reading this part, and I read it with them. And you got to read it many times, not just once. Because the students are expected to produce a book that is commensurate to the level of the course, which means it should not be completely based on mathematics listed in the prior learning. That is the prerequisites. The mathematics should be either part of the syllabus at a similar level or slightly beyond. I read this very slowly, not as fast as I'm reading right now. However, mathematics of a slightly beyond the syllabus is not required, and that not is emphasized to achieve the highest levels. So I help them see that even if they're trying to go beyond what is required, that is not the criteria for getting a higher level. It is the process. And so, as they go with it, at the end of the day, it's their choice. Of course, like Jalaj said, it should be their interest. If they're interested in something that is beyond the level of the syllabus, that's up to them and nobody's going to stop them. But at the end of the day, they need to realize that, hey, if you're going to do something from, beyond the syllabus, that's their time. They're going to invest some time into that. So right from grade 11, when we prepare them, keeping the document in mind. See, they should not come to the end of it and saying, oh, I wish I'd known that I didn't have to put in so much time, because it's not just the math IA they're working on. They're going to be working on several other IAs. So that one statement and show them that, hey, you are free to do whatever you want beyond the syllabus, but that's not what's going to give you the highest score.
Purvi, I think you can go ahead.
No, I just wanted to extend to what Shraddha was saying. Even I do mini IAs in the first year. But what you can do is you can assess students on any two of the criteria or three, not all of them.
Yeah.
And maybe they could extend, I allow them to take it forward as their final IA. And some of them want to change as they go ahead with the syllabus. So it will be a good idea to start off with a mock, or you could say a practice IA, and just assess them on the first two or the first three criteria.
Right. Yeah.
So that would help. And I just had a question, why is it that in mathematics they're not thought about, reducing, not the syllabus, actually, I'm looking at the
yeah.
I mean, being online, it's becoming so difficult. So why they've not considered, removing paper 3? Because
I mean, we should write again.
I think so, we should do that.
Ramesh also has a, thank you, Purvi. Ramesh has a question. Please go ahead, Ramesh.
Yes, ma'am. First of all, thank you for a very nice workshop. And I would like to talk about time constant during this pandemic. Actually, in my school, we are supposed to teach from his publication. So, of course, we have students, but most of them, they don't do anything at home. So how to manage the syllabus in a specified time, or what the process I'm adopting now? First, I take them through that his publication. Of course, I'm not asking them to do all the questions, but all type of questions I explain to them. Then directly I'm taking them to that, IB documents questions, the previous year's questions. And I do agree with Mr. Jallas that we should use technology as far as possible, because if we use technology, it will improve the accuracy as well as time also. They can do the things fast, not during examination, but during class also. So, so you can let me know, is that fine, or do you think I should go for something more?
I have 2 pointers here. I don't know whether Jalaj and John will agree with me. Firstly, with regard to Purvi's suggestion of criteria, I mean, I wouldn't prefer to assess on just a few criteria, because I feel that the criteria act as a network. Like, if I focus only on personal engagement, then I feel that the math might suffer. If I focus only on criterion A, the personal engagement might suffer. So I prefer to, instead of giving the whole weightage for all criteria, give it a slightly lesser weightage, but address all criteria. That is one way I like to work. And secondly, to answer your question, I don't follow only one book, and I'm sure I think Jalaj and John also would agree that there are, I think by now, almost some 4 or 5 authors: Pearson, Hayes, Oxford. Then I think there's Cambridge, not Cambridge, but Hodder. Exactly. Yeah, Hodder's also out. So I think all of them give a diverse range, and Hodder also has a beautiful dynamic learning system. So if the school has funding, go ahead and use the dynamic learning system. It comes with built-in teacher-fed resources, which is really handy. I think based on what we already said, like backward planning, which is, to use Mr. Jalaj's word, the brahmasta. If you do your backward planning well, syllabus completion should not be a problem. And I think if students don't see the seriousness of the course, then they should drop levels and they should reconsider the level they are in. I think we have another question from Mark. Mark, go ahead, please.
Good evening. This is Mark, Ms. Revati, and Mr. Hassan. We know each other. Right. First of all, thank you so much for arranging this. It's going good. The people are those who are discussing here, I could see they are able to complete the syllabus. I have pointed out certain things depending upon that student's background. They are coming from different areas. These are all. Okay, how many periods ideally they are in your school getting for going with the higher level subjects in 11th grade and 12th grade? How long time?
It's not only about the period, it's also about the session of each period. So I think it differs. Some schools have around 90-minute sessions. Some have around 1 hour.
Of how many? That's the thing.
Around, you can say around 3 periods a week.
In my school for higher level, we have 4 periods in a week, and each class is 50 minutes. But we teach in 3 only, and one is we call it office hour in this COVID scenario when we are teaching online. Otherwise, we have 4 periods face-to-face, 50 minutes each.
Okay. In my case, 35 minutes of 4 for in 11th grade. Maybe in 12th grade, we may get 1 more period. So we are struggling like anything.
Do you mean 240 hours if you do just 35 minutes? I think you would.
70, 140 minutes per week. Yeah, it is. That's why ample amount of syllabus is not covered, but still we are forcing them to get a topic for IA. So what topic will they bring?
But I wonder, why is it just 35? Are your school hours shorter?
Yeah, almost like we have other activities too, not only the academic. It is inclusive school. We expect that whole education with all those. So we allotted for some programs other than the normal teaching.
Yeah, we also have we also believe in holistic learning, but we don't do this on cost of any subject topics. So
because ultimately when we get 4 lessons in higher level means then ultimately other things are taking place. It's understandable now.
But 240 hours allotted by IB is possible because your school.
I don't think so.
Yeah, I think
we are trying with the compaction. That much time we never ever got. That much time we can't get it.
That is the benchmark, I would think. Yeah.
So
they are trying to do with compaction, but that compaction also not working. That's what I said. Students are coming from. You see, if the students are from IGCSE and MYP, complete MYP background, I can start 3D vector directly. But students are from different background in the Indian board. So they do not know about what is vector. So then I have to initiate from there. Even sine rule, cos rule, I have to initiate from there. So because of that, so everywhere we have to start from the beginning. Without that, how will they get it? So overall, we are struggling to complete the syllabus.
I think one thing that can help here is incorporating, some kind of self-directed learning where the learner is given pre-prepared notes on the earlier part. And then you can directly start with the 3D vector. And as you're doing the 3D vector part, just introduce the vector part side by side. Something like that could help, because I remember I had a similar kind of a situation sometime back when I had to teach 2 different syllabi in 7 months.
Yeah, I agree.
So
And
we have to find some new way. Yeah, it is experience.
I think the
One time
blended teaching will certainly help. And now finally, like talking about what Purvi and Greta were discussing about the specific criterion for internal assessment. I totally agree with Greta. And I would never do like just looking at a personal engagement or looking at reflection or use of mathematics. It has to be like one full package, looking at everything together, and not even like giving an emphasis to any particular topic. It has to be complete topic to be completed, because if there is no method good communication, it won't add to personal engagement. If there is no good reflection, then the communication presentation, they are all connected. So we
yeah,
can't actually
everything is
consider it.
integrated.
Yeah.
Exactly.
And
I too have that same understanding. Correct.
yeah, and talking about like what Sanjeev, I think did Sanjeev mention about his mathematics and different books?
Ramesh
Ramesh,
mentioned.
yeah. So Ramesh, what we do here in my school, we have a benchmarking document. We do not depend much upon the books. We have three different types of benchmarking. One is the benchmarking at the content level, at a different grade level, what is expected. Second is benchmarking at concept level and the skill level. So we do not look at like in year what they are doing in year 9, 10 from the book. For example, in year 11, they should know when it is quadratic function. They should know what is the quadratic function. They should know how to find minimum, maximum. So what are the skills associated with this? So we do mapping of those skills, mapping of concepts, and mapping of contents. So we don't depend much upon the textbooks later. So, and you don't actually have to do everything which is there in the textbook. Textbooks are just support. Those are not official IB textbook.
Yeah, so I think we can have another session on that to discuss further.
Yeah.
But today I think we
should. I think
yeah, we should.
Yeah,
Yeah, definitely
because
we will have one more session specifically on the topic of like what we have discussed today. So it was a very interactive session as well. So thank you, Jalaj, thank you, Brita, thank you, John, and thank you all the participants, all the teachers from different schools whom they have shared their thoughts, and yeah, definitely we can have one session. So once again, thank you from our side. If you have any doubt, any question related to anything, you can just contact us on the details given on the screen.
Thank you.
Thanks everyone.
Thank
Thanks
you.
for joining. Bye-bye. Thanks,
you.
Mary, for joining.
Thank you, everyone. Bye-bye.
thank you all. Yeah, thank you. Bye.
Bye bye.
Thank you so much.